Okay, moving on to chapter 3, section 2. This will be part 1. We'll do part 2 tomorrow. Talking about linear functions. When you hear the word linear, what do you think of?
Line.
Good. Lines, right? So we're talking about lines today. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b. Everyone write that down. Y equals mx plus b.
Oh, man.
Can you see that?
Not these again.
Y equals mx plus b. A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b, where m and b are constants. So m and b are just numbers. That's what a constant is. Okay? The graph of a linear equation is a line, go figure. So good thing you guys said line when you hear linear. Likewise, a linear function, talked about functions the past 2 days, correct? How do I tell if a graph is a function or not? Vertical line test. So a linear function is a function whose graph is a non-vertical line. Why do you think we exclude vertical lines for linear functions?
Because it wouldn't pass the vertical line.
Very good. It wouldn't pass the vertical line test. A vertical line is not a function, is it? So we cannot include it as a linear function. So any other line that's not vertical is a linear function, because it would pass the vertical line test. Any other line would, wouldn't it? So if you have a vertical line, it is a line, it's just not a linear function. Does that make sense? A linear function has a constant rate of change. Can anyone tell me another word for rate of change? Slope. Rate of change just means slope. So, a linear function has a constant rate of change or a constant slope, and can be represented by a linear equation in two variables. A nonlinear function does not have a constant rate of change. It does not have a constant slope. So its graph is not a line. So the gist of this, if it's linear, it's a line. If it's a linear function, it's any line except the vertical line. If it's nonlinear, it's not a line. Right? Also, if it's linear, it has a constant rate of change. That means the x and y values are increasing or decreasing by the same thing each time. If it's nonlinear, it does not have a constant rate of change. That's the gist of it. Does that make sense? Okay. Let's look at some examples. I can come back to that slide if I need to. Example 1, identifying linear functions using graphs. It says, does the graph represent a linear or nonlinear function? Explain. So let's look at letter A. Can everyone see the graph on letter A? Kind of, at least. We actually hit the second light switch. Maybe it'll let you see a little better. That help at all?
Yeah.
Okay. So, letter A. Would this be, someone raise your hand and tell me if it would be linear or not or nonlinear and why?
Non-linear.
Why?
Because it doesn't have a constant rate of change.
And?
And it's,
It's not a line,
yeah.
right?
Definitely.
So, nonlinear, my explanation in this case could be, it is not a line, and it does not have a constant rate of change. Does everyone know how we get our rate of change? Are we sure? There's points on the graph.
All right.
So how do I get from this top point to this bottom point? Going down how many? 3. So negative 3 over, how far do I go over?
1.
So negative 3 over 1. What about this one right here? How do I get from here to here?
1.
Negative 1 over 1. Is that constant? Is that the same number? No. So that's not a constant rate of change. Does everyone see that? So either one of those could be my explanation here. It's nonlinear because it's not a line, and it does not have a constant rate of change. Questions on A? Letter B. Is this linear or nonlinear, and why? Omar.
Linear.
Linear. Why?
Because it is a line.
It is a line.
It's not curving like the other one, and it has a constant rate of change.
It is a line, and it does have a constant rate of change. We can tell that from our ordered pairs on the graph. To get from the bottom dot to the middle dot, I'm going up how many?
Up one.
Up 2, right?
One.
To get from the middle dot to the top dot, I'm going
Up two over.
up 2, right 1. It's constant. It's the same thing, correct? So I know the rate of change is constant. Does that make sense for A and B? Any questions on it? Pretty easy?
Yes.
Okay, can I move on?
Yes.
Okay. Okay, now I don't have a graph anymore. I just have tables of values.
Ooh. I got this.
Does the table represent a linear or nonlinear function? Explain. How do you think I'm going to do this?
On me?
Mm-hmm.
It's going to be a linear function.
Why? How do I know that?
Because it has a constant rate of change.
How do you know that?
X values, it goes up by 3 each time. And by the Y values, it subtracts 6.
Very good. So if we look at our x values, how do I get from 3 to 6?
Add 3.
Add 3. 6 to 9.
Add 3.
Add 3. 9 to 12. Add 3. So my x is increasing by a constant rate, correct? Now I got to make sure my y is also increasing or decreasing by a constant rate. What do I do to get from 36 to 30? Subtract 6. 30 to 24. Subtract 6. 24 to 18. Subtract 6. Is my y decreasing at a constant rate of change? Yes. So since my x and my y are both increasing or decreasing by a constant rate, it is a constant rate of change. So is this linear or nonlinear? Linear. So in this case, I would say linear. My explanation would be it has a constant, and I'm going to use ROC, and I'm okay if you do that as well. It has a constant rate of change, so I know it's linear. Does that make sense?
Yes, sir.
So if I graph these ordered pairs, it would just make a line. Okay, letter B. What do I do to get from 1 to 3? Add 2. 3 to 5. Add 2. 5 to 7. So are my x values increasing or decreasing by a constant rate?
Yes.
Yes, they are. Don't stop there. We can't just see our x is going at a constant rate and say, oh, it's automatically linear. I've got to check x and y. What do I do to get from 2 to 9? Add 7. 9 to 20. Add 11. 20 to 35. Are my y values increasing or decreasing at a constant rate? No, they are not. So is this linear or nonlinear? Nonlinear. And then my explanation would be it does not have a constant rate of change. Everyone see that for B? Any questions on it? Is that pretty easy? Perfect. That's what I like to hear.
Yes.
Can I move on? All right. Okay, don't get freaked out. These are a bunch of different equations. I have an equation here, 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 and here. That's not one big long equation. Those are all separate. So it says, which of the following equations represents linear functions? Explain. Raise your hand if you can explain to me how I'm going to decide if it's linear or nonlinear from an equation.
You can check if it's in the form of y equals mx plus b.
I need to see if I can get it into this form right here. Y equals mx plus b. You guys all wrote that down, correct?
Yes.
M and b are just
Numbers.
Numbers, constants, right? So I'm trying to get my equations into the form y equals some number x plus or minus some number. Okay? So let's start with y equals 3.8. Raise your hand if you think it's linear. Raise your hand if you think it's nonlinear. So everyone's going nonlinear? I disagree. I concur. M and B are just numbers, correct?
Yeah.
Is 0 a number?
Yes.
Yes, it is. That would be y equals mx plus b form of y equals 3.8. What's 0 times x? 0. So that's why it's not written in the original equation, because you don't need it. Because 0 plus 3.8 would be 3.8. Right? So can this be written in y equals mx plus b form? Yes, it can. So this is linear. Does everyone see that? That one's kind of confusing right off the bat. I'm sorry. Any confusion on that one? It was kind of confusing at first, but do we understand it now?
Yeah.
If I graphed this line, it would just be a horizontal line. Okay? Next one. Y equals square root of x. Y equals the square root of x. Is there anything I can do to try to get that square root off the x to where it'll be in y equals mx plus b form?
Yes.
What could I do?
You can square it.
So if I square it, I've got to square both sides. So I'd get y squared equals x. Do I want to square it on the y?
No.
No. So if I wanted to square off the y, I'd have to take the square root of both sides. And I'm just back to my original equation. So is there anything I can do to get rid of it?
No.
So is this linear or nonlinear? Nonlinear. So for the first one, my explanation would be it's linear because it can be written in y equals mx plus b form. This one, the second one, it's nonlinear. My explanation would be because it cannot be written in y equals mx plus b form. Does that make sense? Okay. Y equals 3 to the x power. That's not 3 times x, that's 3 to the x power. Is there any way I can rewrite that, rearrange it to where I'm in y equals mx plus b form?
You square the x. Oh, like you.
If I wanted to get rid of the x on the 3, I'd have to take the x root of both sides. But do I want that x root with y? No. So is this linear or nonlinear? Nonlinear. Because it cannot be written in the form y equals mx plus b. Everyone okay with that? Okay. Y equals 2 over x. How would I get the x out of the denominator there? Multiply by x. That'd cancel out, but I got to do that over here, correct? So I get xy equals 2. Is that y equals mx plus b form? Is there any other things I could do to get it to y equals mx plus b? No, so what is it? Nonlinear, because it cannot be written in the form y equals mx plus b. Everyone getting the hang of this? Pretty easy? Okay. Y equals 6 times x minus 1. Any suggestions here? Distribute. What's 6 times negative 1? Negative 6. Oh, interesting. Does it?
Yeah.
Is it y equals mx plus b?
No.
No, it's not. Come on.
It's minus. Is that okay or not okay?
It's okay. It's okay.
Is it okay?
Yeah.
This is okay. Because I can rewrite it like this. If I subtract a number, it's the same thing as adding its negative. So my b value is just negative, right? This is still y equals mx plus b. I can have negative numbers, right? B is just a number. It can be negative. So I could have stopped here, 6x minus 6, and said that is slope-intercept form. Okay? Because that means the exact same thing as this right here. Does that make sense for that one?
Yeah.
So is this linear or nonlinear? Linear. Because why? What's my explanation?
It can be written y equals mx plus b form.
It can be written in the form y equals mx plus b. And my last one, x squared minus y equals 0. Trying to get y by itself, right? To get it in y equals mx plus b form. How would I get y by itself here? Add y. So I'd get x squared equals y. Do I want that squared term with the x though? So if I want to get rid of it, I'd have to square root both sides. But do I want the square root with y?
No, you do not.
No. So is there anything I can do to get it y equals mx plus b?
No, unfortunately.
So non-linear, because it cannot be written in the form y equals mx plus b. Everyone good with that?
See, yes, sir.
What if I give you y equals 2x?
Yeah. No, wait. I was Josh.
There's no B. Well, it could be. Zero.
What?
You could add 0.
There we go. It's linear.
Told you.
You can just add 0, tack the at plus 0 onto the end, and it makes it y equals mx plus b, right? So that is linear right there. Okay? Any other questions? Comments, concerns? Are there any questions for me before I end the recording? Oh, wait, I'm not going to end the recording yet because we got to get to our assignment. Here's our assignment. Pages 119 through 120. Numbers 5 through 26 all. Due Monday the 25th on Canvas. Some of these go pretty quick though. Like the graphs. If it's a line, you say it's linear because it's a line. Right? If it's not a line, you say it's nonlinear because it's not a line. Those go pretty quick. The table of values go pretty quick too. You just see what x and y are increasing or decreasing by each time. If it's constant, it's linear because it has a constant rate of change. If it's not constant, it's nonlinear because it doesn't have a constant rate of change. Right? The ones that take the most time are probably the equations because you're trying to get them in slope-intercept form. Y equals mx plus b. But still, that doesn't take too much time. Now, are there any questions before I end the recording?